Let's go to see chapter 9, and I will cover it in two parts, part 1 and part 2. Part 1 is going to be until slide 13. So we will talk about confidence intervals. We have three cases. Two cases when for the population mean, when sigma is known, the standard deviation of population is known, and when sigma is unknown, we know the standard deviation of the sample. And case number 3, when you look for the confidence interval for the population proportion. Quite often we can estimate a population parameter based on a sample statistic. X bar is a sample statistic for mu, PS is for the population proportion. So most of the times we don't know the mean. So the mean, the mu is unknown. As a result, we choose a sample, let's say a size of 20, 30 and so on, and we calculate the sample mean. So based on the sample mean, we can estimate that we are confident that the population mean will be between 40 and 60. All the time we have to use a confidence level or a confidence interval. The most common confidence interval is the 95%. So this is the explanation. In the long run, 95% of all the confidence intervals that can be constructed will contain the unknown true parameter. The true parameter could be the population mean or the population proportion. So the confidence interval, the confidence level will be given, could be 90%, 95, 99 and so on. So let's go to see case number 1. As you can see, we will focus on the population mean. Case number 1, when sigma is known. So in the problem you must have the population standard deviation is, and the key word is population, because a standard deviation always will be given. You have to figure out if it is the standard deviation from the sample or from the population. So in this case sigma is known. So we have to use the formula x bar plus minus z times sigma over square root of n. X bar is the sample mean, sigma is the standard deviation for the population, and n is the sample size. Now the z, you have to calculate it based on the confidence level, and these are the steps. Let's say for example that you are looking for a 95% confidence interval. So what you do is that you divide the 95 divided by 2, or 0.95 divided by 2, and this is 0.475. So then you have to check inside the table for 0.475 and outside for the z-score. Let me bring for a minute the table of the normal distribution. So in this case you look inside for 0.475, and here it is. So 0.475, why 0.475? Because you have 95.95 divided by 2, and then you check the z-score. So it's going to be 1.96, as you can see. Another one, if you have 90%, if you divide by 2, this is 45.45. So in this case, as you can see, the closest will be the 0.4495 or the 0.4505. So if you say 164 or 165, 164 or 165, this is going to be correct, even though the exact one is going to be exactly the average, 1.645. And one more, let's do the 80% confidence interval. 80%, it's 0.8 divided by 2, it's 0.4. So let's see for 0.4. For 0.4, the closest one is this one, 0.3997. So the z-score will be 1.28. So let's go back to the PowerPoint slides. This is the formula, and this is how we calculate the z-score, but you must have in front of you the table of the normal distribution. Then the 99%, same steps, you take 0.99, you divide by 2, this is 0.495. So you have to check inside the table for 0.495 and outside for the z-score. And if you do that, the z-score will be 2.58. and these are the most common confidence levels. As you can see, we have it for 80%, 90, 95 and so on. The most common are the one in the blue color, 90, 95 and 99%. Let's go to see example number 1. In this case we have a sample of 11. We have the mean is 2.2, and then we know the population standard deviation. This is a key word, population standard deviation, and we have to create a 95% confidence interval. So for the z-score for a 95% will be 1.96 by following the same steps. So we have x bar plus minus z times sigma over square root of n. This is 2.2 plus minus 1.96 for a 95% confidence interval times the standard deviation divided by the square root of 11, the sample size. So this is going to be from 1.99 to 2.4068. And this is the explanation that we are 95% confident that the true mean resistance is between 1.9932 to 2.4068. Now let's go to do the same example by using the graphing calculator. I'm gonna have the graphing calculator here. So let's go to do exactly the same numbers, and as you can see, I'm gonna use a sample of 11, 2.2 and 0.35. So for the graphing calculator you have to go to Stat, Tests, and you go to number 7, Z interval. Stats, highlight stats, then sigma, and let's go to see what is the value for sigma. Let me check. The value for sigma is 0.35, so 0.35. X bar is 2.2, N is 11, and the confidence level is 95%, so we keep it as 0.95, and then click calculate and enter. Highlight calculate and then enter. And these are exactly the same values, 1.993 to 2.407. And this is how we use the graphing calculator. One more time, you go to Stat, you go to Tests, and you go to Z interval, number 7. Highlight stats, sigma, x bar, n, and the confidence level. And this is how you calculate the confidence interval by using the graphing calculator.